Hello, geometry students. Mr. Zacek back and better than ever with you here in Unit 11, Lesson 3. We're going to determine if a point lies on a circle. So what we want to do in this lesson is answer the question, how do we determine if a point lies on a circle? And so there's two ways to determine that. And the first way is to determine if the points in x, y coordinates satisfy the equation of a circle. Another way we say that is if it's true. So I'm going to walk you through how to do that with some examples. So prove or disprove that the point 3, the square root of 7, lies on the circle centered at the origin and containing the point -4, 0. So centered at the origin. So here's our process. Number one is we want to identify the center of the circle, centered at the origin. So our circle is 0, 0. So now we need to determine the radius of the circle. So for us, we're centered at 0, 0, and then it's containing the point -4, 1, 2, 3, 4, 0. So that means that the circle, here is our circle, centered at the origin, containing that point. This has to be our this circle tool on here is like very hard to get to be accurate, so I'm just going to try and get it there. Okay, so the nice thing about this question is determine the radius. We can determine the radius by counting in this case. So r equals 4. We might, in this case, in other instances, if it's not a horizontal or a vertical line, we might need to use the distance formula. X2 minus X1 quantity squared plus Y2 minus Y1 quantity squared. Take the square root to find the distance. Okay, so now we're going to write the equation of the circle. Remember, form is x minus h quantity squared plus y minus k quantity squared equals the radius squared. And when the center of the circle is at the origin, it's just x squared plus y squared equals, in this case, it would be 16 because 4 squared is 16. All right, so the final step then is once we have the equation of our circle, substitute the point into the equation of the circle to determine if the points x and y coordinates satisfy the equation of the circle. So our point here is 3, the square root of 7. So there's our x, there's our y. So is 3 squared plus the square root of 7 squared equal to 16. So 3 squared is 9, the square root of 7 squared is 7, and as that equals 16, 9 and 7, 16 equals 16. That's true. All right, and then we're going to write a concluding statement, and so we would say 3 times the square root of 7 lies on the circle because it satisfies the equation. It satisfies the equation of the circle. All right. So there's kind of our outline for do it. So basically, find the equation of the circle, substitute, and see if it's true. All right, so prove or disprove that the point 1 square root of 6 lies on the circle with center at -1, 0, containing the point -1, 3. Okay, so I'm going to go to the next page. Just I think I've got a little more space there. So the center is -1, 0. The point, what's the point? The point is -1, 3. Okay, so the center point, -1, 3. And then the point that's in question was, what was the point that's in question? 1 square root of 6. So 1 square root of 6, that's our point that we're in question. I think it's helpful to Just kind of sketch a graph of this here. So we've got the center as -1, 0, and then the point on the circle is -1, 1, 2, 3. So the reason I point that out is because there's your radius, right? And you can easily see that when you graph it, that there's the radius, and we can see that we can count the radius. We don't have to go ahead and do, the distance formula. Okay, so again, our formula, x minus h quantity squared plus y minus k quantity squared equals r squared. Our center is our point hk, and the little trick is we're just going to switch the signs. So this will be x plus 1 quantity squared. Since it's 0, this just becomes y squared equals 9, because 3 squared is 9. So now we're going to take our point that's in question, and we're going to substitute this in. So does 1 plus 1 squared plus the square root of 6 squared equal 9? So 1 plus 1 is 2. Does 2 squared plus 6 equal 9? Does 4 plus 6 equal 9? Okay, 10 does not equal 9. Okay, so we could write a concluding statement. So 1 square root of 6 does not lie on the circle because it does not satisfy the equation. Does not satisfy the equation. Okay, so here we go. All right, prove or disprove that that point lies on the circle centered at the origin containing the point 6, 0. So again, I'm just going to kind of draw this out. 1, 2, 3, 4, 5, 6. 6, 0 is that point right here. When I draw that out, I can see that my radius is going to be 6. So that makes this a little bit simpler in terms of our equation. So it's going to be x squared plus y squared, since it's at the origin, and equals 36. That's the equation of the circle. So now the point in question is the square root of 18 squared plus 4 squared equal 36. So this would be 18 plus 16. Does that equal 36? And 18 and 16 is 34. 34 does not equal 36. So 18.4 does not lie on the circle. All right, so that's method 1. The other way to determine if a point lies on the circle is to determine if the distance between the point and the center of the circle is the same length as the radius. So here's another way of doing it. So prove or disprove that the point 4, -4 lies on the circle with a center of 1, 0 containing the point 1, 5. Okay, so again, I like to just kind of sketch these out. Sometimes it makes our distance a little bit simpler. So 1, 0, and then I've got 1, 1, 2, 3, 4, 5. Okay, so 1, 5. So our radius for that one is 5. So now the point in question, we'll use green here, is 1, 2, 3, 4, 1, 2, 3, 4. So 4, -4. And our center, and we're wondering, does that come out to be 5? That's kind of the question. So if we already know the radius is 5, so if we take 1, 0 and 4, -4, and there's our x1, y1, x2, y2, and we find the distance. So the d here stands for distance, not diameter, which is x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and we're taking the square root of that. So this would be 3 squared plus negative 4 squared. So that would be the square root of 9 plus 16, which is the square root of 25, which is 5. So determine the radius. I kind of did the work. This work is the work down here. So is the so what do we notice? Well, the radius and the distance are the same. So 4 negative 4 lies on the circle because the distance from the center is the same as the radius, or is the same length as the radius. All right, so what makes something a circle? Well, what makes it a circle is it's equidistant from the center. It's all the points that are equidistant from the center form a circle. Okay, so let's try this one again. So prove or disprove that the point 1 square root of 3 lies on the circle centered at the origin containing the point 0, 2. Again, I always like to graph, just kind of start off with a graph. So centered at the origin, 0, 2. Okay, that allows me in this case to get my radius. Okay, so the radius is going to equal 2. And now the point in question is, so we got 1 square root of 3, and the center again is 0, 0. So x1, y1, x2, y2. Doesn't matter which order you pick those in. So x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. Taking the square root to find the distance. Take the square root to find the distance. So this would be square root of 1 plus 3, which is going to be the square root of 4, which is 2. So prove or disprove that the point is on the circle. So yeah, that's on the circle because it has the same radius. So 1 radical 3 is on the circle. Okay. I'm going to skip 6 and I'm just going to go down to this one here because I think you kind of get the idea of what we have to do there. But this is one. Now write the equation of a circle whose diameter has endpoints negative 2, 4, and 6, 8. So again, let's just kind of sketch ourselves a picture here. That always helps to with these questions. So we've got negative 2, 1, 2, 3, 4, negative 2, 4, and then we've got 1, 2, 3, 4, 5, 6, 4, 5, 6, 7, 8. Extend this up a little bit here. All right, so that's the diameter. Well, the deal here is we need to find the midpoint. So the midpoint formula, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. The midpoint formula, that's for you. You have to add and divide by 2. So the center is the midpoint of the diameter. So negative 2 plus 6 divided by 2, and 4 plus 8 divided by 2. So the center then, therefore, would be, if we just simplify that, it'd be 4 divided by 2, which is 2, and 12 divided by 2, which is 6. So 2, 1, 2, 3, 4, 5, 6, poorly drawn line. So we got the center. Now, what else do we need? We need to know the length of the radius. So what I'm going to do here to find the radius, so the radius, I'm going to pick the center point, and I'm going to pick one of the endpoints. I'll just go with 6, 8. I'll label that my x1, y1, x2, y2. So the radius is going to be 6 minus 2, x2 minus x1, quantity squared, plus y2 minus y1 quantity squared. So what I'm finding right now is I'm finding this distance from here to here. I could have gone to the other point. Either one would work. I picked this one because both the numbers were positive. So this would be 4 squared plus 2 squared. So the radius is going to be 16 plus 4. The radius would be the square root of 20. We could simplify that, but I'm going to leave it just like that for the sake of our question. And now we want to write the equation of a circle. Well, there's our x minus, here's hk, x minus 2 quantity squared plus y minus 6 quantity squared equals the square root of 20 squared. So this would be x minus 2 quantity squared plus y minus 6 quantity squared equals 20. Okay, so just adding some different layers on here of ways that we can see this question, right? Then we could add, is the point on the circle? At that point, we could plug it in and check or use one of our methods there. So there you have it, all right? And we got a little lab that's a review, and then we're going to take a quiz here on this. So this will end our section on equations, and next thing we're going to do is we're going to look at angles related to circles. I'll see you back here soon.